This video is about thermal energy transfer. We have learned in subtopic 3.1 that when there is a temperature difference between two regions, energy flows from the hotter to the colder region. There are three different ways in which this energy flow can happen: conduction, convection, and thermal radiation. Even though some conduction happens in liquids and gases, it is the most significant and evident in solids. The finer details of conduction are relatively complex, but in general we can say that conduction happens through two mechanisms. The first involves atomic vibrations. Imagine that we are heating one end of a metal rod. As a result, atoms at this end of the rod vibrate faster and faster. These vibrations then are passed on to neighboring atoms, which means that temperature increases all along the rod. Recall from subtopic 5.1 that most metals contain a cloud of free electrons. The second conduction mechanism is through the movement of these free electrons. A key point here is that atoms in the solid do not move from one place to another relative to each other. They simply vibrate about a fixed position and pass on these vibrations to neighboring atoms. Logically, materials that are good electrical conductors are usually also good thermal conductors. Examples of conduction include the end of a spoon becoming hot when the spoon is placed in hot tea, and a chocolate bar melting in your hand. Convection is the movement of particles within fluids, so liquids or gases. This movement is due to density differences in the fluid that arise due to temperature differences. Examples include ocean breezes and convection in the Earth's mantle, which is the extremely hot liquid material that lies between the Earth's crust and core. Thermal radiation is energy transfer through electromagnetic radiation. It does not require a medium or a material in order to transfer energy. Energy here is transferred by photons. This means that thermal radiation can pass through vacuum. Examples include the heating of the Earth by the sun and the heat that you feel when you sit by a campfire. In IB physics, you're expected to describe conduction and convection only qualitatively, so basically as we have done so here. We'll explore thermal radiation in more detail in some of the later videos. This completes our discussion of thermal energy transfer.